moment. Okay. Hello, everyone. My name is Zhang from Tsinghua University, Beijing, China. I'm going to talk about methodology and real-world applications of dynamic uncertain causality graph for clinical diagnosis with explainability and invariance. This topic is the same as the title of my newly published paper in Artificial Intelligence Review. So if anyone who is interested in the details of my presentation, you can look at this paper. As you know, UN General Assembly passed a resolution on artificial intelligence this year, which requires promote safe, reliable, and trustworthy AI systems, promote transparency, predictability, reliability, and understandability throughout the life cycle of AI systems that make or support making decisions that affect end users, including by providing notifications and explanations. Dynamic uncertain causality graph, briefly DUCG, is such an AI system that is causality driven, has been applied in the real world in China, and meets all the requirements without problems of high cost and high energy consumption. Clinical diagnosis is one of the applications of DUCG, which is the topic that I'm going to talk about in my presentation. Here you see DUCG cooperates with clinical experts instead of data. The first step is to determine the chief complaint that the expert is good in, and then list the disease that may cause the chief complaint. The second step is to construct the single disease modules for every disease listed. For example, here, this is one of the module, and this is the name of the disease. The red arrows represent not only the causal directions, but also the uncertain causal functional event matrices defined in DUCG. DUCG is the understanding of human experts to the real world. The construction for every disease module is the same, no matter the disease is common or uncommon. Therefore, DUCG can correctly diagnose uncommon diseases, which is the real need in practice. The causalities are usually invariant in different application scenarios. Therefore, DUCG does not have the problem of generalization. These are the graphical symbols variables defined in DUCG. For example, this is for the basic event variable. This is for the consequence variable, etc. Uncertainty parameters are encoded in single disease modules. They have clear physical medical meanings and can be specified by the experts directly. Like this one. This parameter, only relative values are meaningful, not the absolute values. And I will, sorry? What does that mean? Can you hear me?
We can hear you. Sorry, this is only for the organizer. Don't worry.
Okay, so I can continue?
Yeah, please.
Okay. Well, I will talk about why only the relative values are meaningful later. After constructions of single disease modules, DUCG synthesizes these modules as a DUCD model for a chief complaint by fusing same variables in different single disease modules. This is one of the examples of a single disease module. corresponding to a chief complaint. So far, we have constructed 48 DUCG models covering 64 chief complaints, covering more than 1,000 diseases. It is seen that such complex professional causalities and behind-the-inference mechanisms are hard to be documented for large language models to learn. In our understanding, professional AI systems should be tools for people to represent and apply humans' professional knowledge instead of just extracting statistical relationships among tokens and generating next tokens without understanding what these tokens really mean. So far, the 48 models are applied in real world in China, in which 46 models were retrospectively verified by third-party high-grade hospitals before real applications. Well, these are the list of these models and chief complaints. This graph is generated during DUCG's inference or diagnosis, which explains why this disease here, why this disease is possible. The green nodes here, these are green nodes, are negative evidences which will decrease the probability of this disease. The other colored nodes, like this one, etc. These nodes are positive evidences that is expected by assuming this disease and will support the diagnosis for this disease. This graph explains why this disease is less possible, because you know here, there are 5 isolated positive diseases that cannot be explained by this disease. So this isolated positive evidences will greatly reduce the possibility of this disease. This slide shows briefly about our algorithm of DUCG. DUCG's diagnosis is to calculate probabilities of possible diseases, HKJ, conditional on evidence E, which is in the equation is in the form of numerator divided by denominator. Therefore, only the relative values of the parameters are meaningful, not absolute values. And this is the formula to calculate the recommendation degree of a state unknown variable xi, which can be a potential medical check. You can find the details of this equation. Here, the beta means the cost to do the medical check, and the omega means the degree, how dangerous of this disease is, and the lambda means how many number of diseases are connected to xi. In our inference process, once a user disagrees with the diagnosis of DUCG, he can click a button on the screen to report this case to us. And once we receive this report, we will look at this case carefully and discuss the situation with the user to make sure who is correct. If DUCG is incorrect, then we will do our revisions about the model and until to get the correct diagnosis. Of course, most of the time, DUCG is correct and was mistaken as incorrect. We will explain that later. This is application results so far. The third-party verifications show that the diagnostic precisions of every DUCG models are no less than 95%, in which the precisions of every diseases, including the uncommon ones, are no less than 80%. DUCG has been applied in 5 county or district areas in China, covering all primary hospitals and clinics connected to the local medical internet. So far, more than 1.7 million diagnostic cases have been performed with DUCG by the local clinicians. Only 17 cases have been identified as incorrect. All the 17 cases were traced to find the mistakes in DUCG. Well, we can find the mistake in modules, and the corrections were made. After corrections, same problems are no longer reported. The diagnosis ability of clinicians who apply DUCG frequently are improved significantly. You can look at this picture. This is the application situation in Jiaozhou city, which has about 1 million population. By the end of 2023, about 660,000 cases had been diagnosed with DUCG. Total of 355 disagreed cases are reported to us, in which 54 are the wrong selection of chief complaint models. For example, the patient has headache and the user use a model of joint pain, etc. 80 cases are the chronic diseases that the patient has known, as they don't want to see the doctor to ask what the disease they have. Actually, they just want to take medicines. 23 cases are incorrect information input. 191 cases are mistaken as incorrect, but after the discussions, DUCG is correct. Only 7 cases are really the mistakes of DUCG. They are traced and corrected. Since then, no report has been found. This is the situation in Zhongxian and other places, which has also nearly 1 million population. By the end of 2023, we have so many cases have been diagnosed. Well, these numbers I don't want to repeat, and you can look at it. The situation is quite similar to the case in Jiaozhou city. This is another place, the Laoshan district, which is in Qingdao province, Qingdao city, Shandong province of China. And also by the end of this 2023, many cases have been diagnosed with DUCG. And 46 cases are reported as disagreed cases. And the case is listed here. Okay, this table shows the group ability improvement rate compared to the year without using DUCG. The group means the group of local clinicians. For example, the first line here, we find that there are 223 clinicians apply DUCG at least once. Just a moment. At least once. And we found that all these clinicians diagnosed 269 diseases in the year before applying DUCG, which is 2019. And in the year 2021, this group of clinicians diagnosed 516 diseases by applying DUCG. So we can calculate the ability improvement rate. We use this number divided by this number and -1, which is 91% of improvement. The other lines are the similar, has the same meanings. This is the improvement rate in terms of individual clinicians. This is the area, this is the individual clinician who apply DOCG. The star means that this clinician is the village clinician. He works in the village clinics. And you can see the improvement rate, almost 100%. This is also, well, it's more than 200%. This chart shows that more and more local clinicians like to use DOCG to do the disease diagnosis. See the green one, the last year's number. And if you look at the average improvement rate of the ability of diagnosis, you can see that the average rate is about 100%. Sometimes they're very high. This chart shows the top 20 models according to the usage of DOCG by the end of 2023. DOCG has no cost and no energy consumption. So far, we have spent less than $10 million in our research, development, and applications. A server without a GPU costing less than $10,000 can concurrently serve hundreds of primary hospitals and clinics in the county or district areas that has up to 1 million population. The inference time is within 1 second per diagnosis. The level of clinical experts determines the upper limit of DOCG because DOCG is constructed by experts instead of being trained by data. DOCG provides text descriptions, standard images, sound, and mini videos for users' reference, but is unable to recognize the medical images and the sound. The data-driven AI can cooperate with DOCG in this area. We have sold the DOCG service to 3 district governments because in China, the primary hospitals and clinics belong to the district governments. The other 2 are free use for test. So far, the reflections from the 5 areas are good. We believe that the DOCG can help all clinicians in the world, but now only Chinese version is available. We need more funding, investment, and cooperation to develop other language versions of DOCG. Well, as you may know, it is very difficult for original theory to be published in famous journals. Even so, we have published 17 papers, DOCG papers, in the journals ranking Q1. These are some of them listed for your reference. Okay, thanks. That's all. Questions are welcome. Hello? Hello? Can you hear me? Hello?
Hello.
Okay.
Thank you,
Any
Dr.
questions?
Zhang. Participants, if you have any questions, please. So I will share the email address of Dr. Zhang.
Well, the last page is my email, is my email address here.
I'm sharing your email address. No problem.
Okay, I can write it
Yes.
and find
Thank
where.
you, Doctor.
Okay.
Yes, we'll move to the next presentation. Thank you, Doctor.